Hello, my dear students. Welcome to today's chemistry class. I welcome you all to Teacher Dot. Yeah, I am Meghana, your chemistry teacher. So, students, I hope you all successfully completed your first PUC and you all are in second PUC now, right? And are you all aware of chemistry second PU portions? So in today's class in the teacher dot, we will discuss about chemistry, your second year portions and what are the basic knowledge you should have to understand chemistry very easily. Okay. Students, let us discuss about the portions first. So whatever the chapters are there in your NCERT textbook is first divided into three parts based on different branches of chemistry as physical chemistry, inorganic chemistry and organic chemistry. So if you see our NCERT textbook, some of the chapters like solids, chemical kinetics, solutions, all this come under physical chemistry and periodic table related like D and F block, P block, coordination compounds, all this come under inorganic chemistry. And the main part of chemistry that starts from haloalkanes and haloarenes, alcohols, phenols, ethers, aldehydes, ketones, carboxylic acid, and it goes on like that. These chapters come under organic chemistry. As I found from long years, most of the students find organic chemistry as a difficult part of chemistry. Students, do you know why most of the students feel it difficult? Because most of them lack the basic knowledge of organic chemistry. That is the main reason, students. So before starting your second PUC organic chemistry chapters, I decided that you all will be having a very good knowledge of basic organic chemistry concepts. I know you have studied in your first PUC. In today's class, let us brush up whatever you know about the basic organic chemistry concepts. Fine. So let's start. So in the PPT, in the first slide, whatever it displayed, students, you can see here. First, let us discuss about the hydrocarbons. So you know hydrocarbons means nothing but alkanes, right? Alkanes, alkenes, and alkynes, right? You all are aware of it, right? What is the difference between alkane, A-N-E, alkene, E-N-E, and alkynes, Y-N-E? It is a, you differentiate based on single bond, double bond, and triple bond, correct? So, what is the general formula of alkane? So, when you move on to alkanes, the general formula of alkane will be CnH2n plus 2. And what is the general formula for alkene? Alkene it is CnH2n. Whereas for alkynes, it is CnH2n minus 2. That means hydrocarbons contains mainly carbons and hydrogen. Based on single bond, double bond and triple bond, we can classify hydrocarbons into alkanes, alkenes and alkynes. So first let us discuss about alkanes. See what is the structure of alkane? RCH3. For example, it starts as methane for one carbon. Students, see if it is one carbon atom in a compound, we use the word meth, M-E-T-H, meth. And if it is a single bond, all the four bonds in a carbon is a single bond, we use A-N-E. So it is methane. You know that? How many bonds a carbon should have? Four covalent bonds, right? If all the four covalent bond is a sigma bond or a single bond, it comes under alkanes. So what will be the formula for alkane? A carbon with four covalent bonds and all the bonds you fill with hydrogen atoms. So the formula will be CH4 for Methane. Now tell me the next carbon, ethane. See, eth is a term used for two carbon atoms. So two carbon atoms, C bond C. Now satisfy the number of covalent bonds. So each carbon should contain four covalent bonds and fill each with how many hydrogen atoms ethane has? Ethane will contain totally six hydrogen atoms. So the formula for ethane will be C2H6 will be the formula for ethane. Is it clear? Or now when I ask you what is the formula for butane, it goes on like that. Methane, ethane, propane, butane, pentane, it goes on. So students, if I ask you what is the formula for butane, how do you tell me the formula? You use the help of the general formula what I said. What is the general formula of alkanes? CnH2n plus 2, right? Using the general formula, you can count how many number of carbon atoms and how many hydrogen atoms are there in butane. So I'll help you how it is. Now but, see, meth means one carbon atom, eth two carbon atom, prop 3 carbon atom. Now let us generate formula of butane. But means you all know it is 4 carbon atoms. So Cn means C4. N equals 4 here. So H 2n plus 2, that is 2 into 4 plus 2. So what is the formula of butane? C4H10. Yes. So the formula of butane will be C4H10. So this is what we call it as alkanes. Methane, ethane, propane, butane, pentane, it goes on. All the carbon atoms will have single bond. Now let us come to the next one, that is alkene. Yes, alkene starts from ethene, propene, butene, so on. So let me help you to write the structure. Now how do you write the structure of propene? Prop-ene, E-N-E, ene. E-N-E, ene signifies that the compound contains double bond. Now prop means three carbon atoms, correct? Three carbon atoms. Now ENE means double bond. Between any two carbon atoms, there will be a double bond. Now satisfy the number of bonds and fill with hydrogen atoms. That will give you propene. So what will be the formula of propene? It goes on with the general formula CnH2n. Prop means 3 carbon atom. So it will be C3H2 into 3, 6. So the formula of propene will be C3H6. Got it? So it goes on like that. Propene, butene. Butene means 4 carbon atom. Pentene, 5 carbon atom with double bond between any two carbon atoms. What does the double bond signifies? In the double bond, yes, one bond will be sigma bond and the another bond will be pi bond. Correct? You remember sigma bond and pi bond? Now next, alkynes. Alkynes, general formula of alkynes will be CnH2n minus 2. You can apply for this formula for ethyne, butane, hexane, heptane. So now for example, ethyne. So let us see what will be the formula for ethyne. It is eth means 2 carbon atoms, C2H2 into 2, 4 minus 2. So the formula is C2H2, right? The formula of ethyne. Now let us write the structure of ethyne, students. So how do you write the structure of ethyne? How many carbons? Ethyne means it is 2 carbon atom. So C, how many bonds when it is YNE? it indicates that between the two carbon atom it is triple bond. Triple bond means one sigma bond and two pi bonds. And CnH2n plus 2 means C2H2. This will be the structure of ethane. So got it? So alkenes, are the basic hydrocarbons that you have to know. Now the next one, diene. What do you mean by diene? You know that ene means double bond. If two double bonds are present in a compound, we call it as diene. For example, in the example that I have given here, students, you observe how many carbon atoms. First count the number of carbon atoms. 1, 2, 3, 4. There are 4 carbon atoms. So when it is 4 carbon atom, what term you will use? You will use the term but, correct? So here, how many double bonds are there? 2. You can find 2 double bonds. Now for example, when you number it, 1, 2, 3, 4. First carbon contains double bond and again the third carbon contains double bond. So we can name it as 1, 3 butadiene. Is that clear? It signifies the butadiene, that is double bonds are in first carbon atom and the third carbon atom position. So you understood how to name 1, 3 butadiene. Same way, students, you can try it for hexadiene as well. So what do you do? How do you write the structure of hexadiene? How many carbon atoms does hexa indicates? It indicates 6 carbon atom. Hexa means 6, right? Yeah, 6 carbon atom. Now for example, if I add double bond to between any diene, any two carbon atoms, and satisfy with number of hydrogen, it will be CH2, CH, CH2, right? Count the number of bonds, CH, CH2. Now this is hexadiene, and when you number it, it is 1, 2, 3, 4, 5, 6. So it is 1, comma 4. So what will be the name of this diene? It is 1, comma 4 hexadiene. Is it clear how to name dienes? So this is a basic thing you all have studied in your first year. And the most important concept that you should be thorough with is the functional group, students. So let us discuss what are the functional groups that we study even in our second year. We study in depth of the concept. In this class, we'll just brush up some of the functional groups and how to do the IUPAC nomenclature of all these functional groups. First, let us start with alcohols. Students, how do you identify alcohol functional group? So you'll identify with the OH formula, right? If OH group is attached to any of the alkyl part, it is called as alcohols. And when we are naming alcohols in the suffix, we use the letter OL. Now, let me give some examples. Students, I'll make it easy for you. What is methane? Methane means CH4, right? You write it as METHANE, methane. Methane carbon atom is covalently bonded to 4 hydrogen atom. Students, now what you do, remove one hydrogen. In the place, you substitute OH functional group. So it becomes CH3. When you remove one hydrogen, it will give you the alkyl part, that is methyl CH3, and add one OH functional group, alcohol functional group. Is that clear? I had a hydrocarbon methane. Now what I did? Remove one hydrogen. and add OH functional group, and the formula will be CH3OH. Now how to name this CH3OH? Just you erase in methane. See, this is a very simple way I'm explaining you. In methane, just you erase the last E. Okay, the last E you will erase. Add the suffix OL. So what you will get? Methanol. So what is the IUPAC nomenclature of CH3OH? It is methanol. So when it is two carbon atoms, OH group is attached to two carbon atoms, ethyl group, it is ethanol. When OH group is attached to propyl group, it is propanol. Now for example, now let me write the structure of propanol. Propanol means, now what is the formula of propane? CH3, CH2, CH3. This is how you write propane, right? Now what I'll do, how do I write the structure of propanol? It is CH3, CH2, remove one hydrogen from this carbon atom and I will add OH. So now CH3, CH2, CH2OH, three carbon atoms means propane and I will add OL, it is propanol. Is it clear? So I hope you can write the structure. You will be able to write the structure of butanol, hexanol, heptanol. Butanol means 4 carbon atom, hexanol 6 carbon atom. Now students, again in this there is a nomenclature. It goes on in depth. That is how to name the higher alcohols. That when I'm explaining the particular chapter, we will discuss in depth. Now you should know this much basics. Fine. This is about alcohols. Now let us move on to the next functional group, that is ethers. Now students, what is the general formula of ethers? How do I identify ether compound? The general formula of ethers is nothing but, you can see the oxygen atom bonded to two alkyl groups, both the side. Okay, this is a easy way to remember ethers, the general formula of ethers. Are you able to observe here, students? See, two alkyl groups. R indicates the alkyl groups. It can be methyl, ethyl, propyl, any alkyl groups. Oxygen atom is bonded to two alkyl groups. This is how it symbolizes ethers. Okay. Now, how to, for example, let me give some example. CH3 methyl group have taken OCH3, or C2H5 OC2H5. Got it? And it's not a rule that both the alkyl groups should be same. Now whatever I have written is an example for symmetrical ethers. And so if I write example like this, CH3O C2H5, this I call it as unsymmetrical ethers. That means you can see both the alkyl groups are different. So first, you students, you understand how to write the general formula of ether. It is ROR. That means oxygen atom is bonded to two alkyl groups and it can be symmetrical or unsymmetrical. Now, how to name this ether? We use the term suffix oxy. Now example, let me explain you how to name IUPAC nomenclature for symmetrical ethers. Now see the CH3OCH3, this one I can call it as methoxymethane. Okay, now this is ethoxyethane. So like that it goes on, methoxymethane, ethoxyethane. Now when it is unsymmetrical, the lesser number of carbon atoms you have to combine with oxygen. Like generally we call it as alkoxy alkane. Okay. Now lesser number, the smaller one, the lesser number of carbon atom you combine with oxygen. So it is alkoxy means here it is methoxy. Methoxy. Alkane means it is two carbon atoms, ethane. So it is methoxyethane. Is that clear? So we use the suffix oxy, or you remember the general name alkoxy alkane. Okay. Now we'll move on to the next functional group, that is aldehydes. So aldehydes, ketones and carboxylic acid. All the three together we call them as carbonyl compounds. You observe here this aldehydes, ketones and carboxylic acid. In general, we name them as carbonyl compounds. Why they are called as carbonyl compounds? Because they all the three have in common carbonyl group. Carbonyl group means C double bond O. Are you able to observe? See? C double bond O. They have carbonyl groups. Now first, aldehyde. What is the general formula of aldehyde? Aldehyde is alkyl group. CHO group is attached to alkyl group. So that means R C double bond O single bond H. This is how the general representation of aldehydes, and when you are naming aldehydes use the suffix Al. Is it fine? So let us discuss some examples for aldehydes, students. Now, a simple aldehyde. Let me take ethanol. See, let me try to write the structure of ethanol. So, ethanol means how many carbon atoms? Two carbon atoms, correct? So, first it is CH3, C double bond O, single bond H. Here you have to count the carbon in the aldehyde group as well. So this is carbon 1 and this is carbon 2. So totally how many carbons? 2 carbon. So you know that 2 carbon atom means ethane. Here also what you have to do, remove the last E and add the suffix Al and it will give you the name ethanol. Is it clear how to name aldehydes? Now for example, let me write the structure of propanol. So students, when it is asked to write the structure of propanol, what you have to do? First you see prop means how many carbon atoms? 3 carbon atoms. So it goes on like this: CH3, CH2. Along with the aldehyde carbon, you have to count the number of carbon atoms. So C double bond O H. So this will be the structure of propanol. Totally 3 carbon atom. And same way, when you understood the how to name ethanol, propanol, you can write the structure of butanol with 4 carbon atoms, hexanol, heptanol, anything is given, you should be able to write. Just add the suffix al. And how to identify? The general formula are C double bond O H. Now, what is the difference between aldehydes and ketones? Bonded to two alkyl groups. That is the difference. Are you able to observe here? The ketones, the carbonyl group is bonded to two alkyl groups, both the side. And when we are naming ketones, we use the suffix ONE. So since I told you two alkyl groups, the first member of ketone will be propanone. You can understand why it is propanone, right? Now let me write the structure of propanone. Now observe students. Propanone. Prop means how many carbon atoms? 3 carbon atoms. So definitely C double bond O indicates ketone group and both the side it is methyl group. CH3, C double bond O, CH3. So both the side you can see methyl groups, and totally how many carbon atoms when you count? 1, 2, 3. So this will be propanone. So propane, you know propane means 3 carbon atom. Erase the last E part and add ONE. Same way, if I try to write the structure of butanone, how do you write butanone? 4 carbon atom CH3, and the second carbon atom, I'll write the functional group ketone, carbonyl group. Next will be CH2, CH3, right? Can you count the number of carbon atoms now? So 4 carbon atoms containing ketone group. So if it is 4 carbon atom, it will be but, and you will add ONE, and it will give you the IUPAC name butanone. I hope it is clear. Are you getting, students, how to name alcohols, ethers, aldehydes, ketones? See why I am explaining, giving a simple examples and explaining you how to name this functional groups, because in your second PUC, in each and every chapter, you will be studying in depth about this functional group. Now, for example, if I take alcohol, now you just know the basics, how to name it and some of the examples. But in your second year chapters, you'll be studying how to prepare, what are the various methods to prepare alcohol, what are the physical properties these alcohols will show, and what are the chemical properties it will show. Like this, we'll study the in-depth studies of all these functional groups. Fine. So, shall I move on to the next functional group? Yeah, it is carboxylic acid. Here also you can find the carbonyl group. What is the general representation? How do you identify carboxylic acid? CO, just a minute. It is COOH. Correct? If COOH group is attached to any alkyl groups, we call it as carboxylic acid. A simple examples like ethanoic acid, propanoic acid or methanoic acid, butanoic acid. How to name this? Very easy way, I'll explain you how to name the carboxylic acid. See, for example, here it is given ethanoic acid. Ethane means how many carbon atoms? 2 carbon atoms. And including the carboxylic group COOH, correct? That means the formula for ethanoic acid is CH3, satisfy with the bonds CH3 COOH. So this is a formula of ethanoic acid. See, acids in general we represented as RCOOH. Now, if alkyl group, I'll write it as CH3, CH2, COOH. So, how many carbon atoms totally, students? That is 1, 2, 3 carbon atoms. So, 3 carbon atom means propane, right? What I told you, erase the last E and add the suffix oic acid. What is the suffix that you have to add for carboxylic acid groups? You have to add the suffix oic acid. Fine. So when you add the suffix oic acid, the names goes on like this: ethanoic acid, propanoic acid, butanoic acid. Is it clear? Now, these are some of the functional groups that you have studied in your second year as well as from your school level, I guess. Now, also, you should be knowing some functional groups like this: amines, nitriles, thiols, esters, and amides. Now, what are amines? Students, generally, you know the formula of ammonia, right? How do you write the structure of formula of ammonia? NH3. Nitrogen bonded to 3 hydrogen atoms. Now, then what is amine? Amine contains, if NH3, if it is NH3, we name it as ammonia. If it is NH2 group attached to remove one hydrogen from NH3 and an alkyl group is attached, then it becomes RNH2, correct? From NH3, you remove one hydrogen and attach any alkyl group. If any alkyl group is bonded, then it becomes RNH2. So what is this NH2? NH2 is nothing but the functional group amine. We call it as amine. NH2 group attached to any alkyl groups. So what is the suffix that you have to add when you are naming amine? It is nothing but the suffix itself you will add as amine. This is a IUPAC nomenclature I am explaining you. Now for example, CH3NH2. Here what I did, the simple way as I told you before, from CH4, CH4 means what? What is the name of CH4? Methane, correct? Now you remove one hydrogen and you have added NH2 group there, amine functional group. So here what you have to do, you have to add the term suffix amine. So it becomes methanamine, CH3NH2. We name it, we call it as methanamine. Now same way, one more example. Let us try to write the structure of ethanamine. Ethane, eth means how many carbon atoms, students? Two carbon atoms. So CH3, CH2, NH2. This is the structure of ethanamine. Is it clear? So like that, amines on when we are studying, there is a chapter called amines. Under that you study more about amines like ethanamine, methanamine, propanamine, and the nomenclature it still goes on in depth. I think you all are excited to know more about it. But for now, you should know this basic how to identify the amine functional group and how to name the basic amine compounds. Fine? You can take a screenshot of it and or make a note of it and practice. Just students, what you have to do is you have to know the suffix of each functional group. Okay, how to identify the functional groups and how to do the IUPAC nomenclature. This basic will be very important. Now we'll move on to the next functional group, that is nitriles. See, this nitriles in general, a simple way I can write it as CN. CN functional group attached to any alkyl, we call it as nitriles. See, when we are naming this nitriles, when you have to add the name in the prefix, we use the term cyano in prefix, whereas we use the term nitrile in suffix. According to IUPAC, we use the suffix part of the nomenclature, that is nitriles, or in some when you are reading the textbooks you can find it as cyano compounds as well. CN is otherwise name called as cyano compounds when you are naming it in a prefix. Okay, now for example here, so and how many carbon atom, how many double bonds are present between the carbon and nitrogen? How many bonds? Triple bond, three bonds. So it is the general representation of nitriles will be RC triple bond N. Now I substitute R with a methyl group. It becomes CH3C triple bond N. Understood what I did now? Once again I'll explain you students. See, very simple. You just have to remember the general formula of nitriles. Okay. So what is the general formula of nitriles given? It is given as RC triple bond N. Correct. Now what you do? Substitute R with CH3 methyl group. If I substitute R with methyl group, it gives me CH3 C triple bond N. So now count the number of carbon atoms along with the functional group carbon atoms. So this is 1, this is 2. So totally how many carbon atoms? 2. 2 means it is ethane and add the suffix nitrile. So it is ethane nitrile. Understood how to name the nitrile groups? Now So can you try to write the structure of propanenitrile? How do you write the structure of propanenitrile? Students, propane means how many carbon atoms? 3 carbon atoms. CH3, CH2, C triple bond and along with the functional group, nitrile group. So 1, 2, 3 carbon atoms. We call it as propanenitrile. Is that clear? How to name the nitrile functional groups? How to identify the nitrile functional group and how to name it. Now, what are thiols? Thio is a name, is a word given to a compound containing sulfur. If any hydrocarbon or any organic compound, if it contains sulfur element, we use this general name thio for sulfur containing organic compounds. So here if you observe, what is the general formula for thiols? It is RSH. Okay. Now what I'll do, I will substitute R with C2H5. C2H5SH. So now how to name this C2H5SH? Sulfur containing compound. I told you the suffix should be thiol. So C2H5 means how many carbon atoms? 2 carbon atoms. 2 carbon atom means it is ethane, and in the suffix what do you add? Thiol. So it is ethane thiol. Is that clear? So thio means any compound containing sulfur. Now for example, one more CH3, CH2, CH2, SH. Now what is this CH3, CH2, CH2, SH? Count the number of carbon atoms. It is 3 carbon atom and it is containing thiol functional group. So I will write it as propan thiol. Suffix I will add thiol. Propan thiol. Is that clear? Make a note of all the functional groups, students, and go through the general formula, general representation, and the what you have to add in the suffix part. Then it will be easy for you. Now next, esters. I think you have heard the reaction called as esterification, where you prepare esters. It is a fruit smelling compound, correct? So in all the chapters you come across this functional group called esters. So you should be able to identify what are esters. So you can see the general formula here. The general formula for esters is RC double bond OR. Okay, now to make it easy, I will write one example. CH3 C double bond OCH3 COO, or general simple way RCOOR, two alkyl groups. You can observe here, this is a general formula of esters. Now R group I have substituted with methyl part. So it gives me CH3 C double bond O CH3. Okay, or it can be C2H5 C double bond O C2H5. So this is how you write the examples of esters. Now how to write esters? By observing this COO, you will identify it as esters. Now how to name this esters? In the suffix, we use the term O8, O8TE, O8. Now for example, here, observe here, whatever example I have written, see, methyl acetate, okay, or methyl ethanoate. Here the CH3 group, CH3COO, it is called as ethanoate, methyl ethanoate. Is that clear? In the suffix you have to use the term oate. or simple one more way I'll explain you how to in simple way to name the esters. Now, previously I explained you how to do the nomenclature of carboxylic acid, right? Carboxylic acid means it is now one simple example of carboxylic acid CH3 C double bond O OH. Now, how do you name this carboxylic acid, students? You name it as ethanoic acid. Correct? Two carbon atoms, so ethanoic acid. Now for esters, what you can observe here is instead of hydrogen, observe here, instead of hydrogen, what I do? I add one more alkyl group here. So what alkyl group I'll add? I will add CH3. Okay. So when I add CH3 instead of hydrogen, count this carbon also. 1, 2, 2 carbon. So what you do? Remove the oic acid part. Instead of the suffix oic acid, what you should add? The suffix OAT. Correct? So the oic acid now becomes OAT. And what you can observe here, which alkyl group? Methyl. So it is methyl ethanoate. Is that clear? Instead of oic acid, you use the suffix OAT. Okay. Now the next functional group, that is amides. Students, amides is nothing but already here you understood what are amines. That is amines means it is identified from with the functional group NH2. Then what is amides then? You can see the difference in the naming, right? This is amines and now this one is amides. It is nothing but if you find the NH2 group with a carbonyl compound attached to a carbonyl group C double bond O NH2 or C double bond O carbonyl group or CONH2. If the amine group is bonded to carbonyl atom, we call it as amides. Okay. See, when it is RNH2, we name it as amines. When it is RCONH2, it is called as amides. For example, CH3 R group, I will substitute with methyl CH3 C double bond O NH2. So how many carbon atoms you can find here? Two carbon atom. Two carbon means ethane. And is it amine or amide? It is amide. So ethane amide. So this is how you name it, ethanamide. So now here it is written benzamide, benzene ring. Benzamide means benzene ring. If it is attached to CO NH2, we call it as benzamide. Did you understand the structure of benzamide? So if you see the amine group attached to a carbonyl atom, one more example, if you can write CH3, how do you write the structure of propanamide? CH3, CH2, C double bond O, NH2. Now what it is? It is called as propanamide. Is it understood? So students, in today's class, you understood what already you brush up with what is alkanes, alkenes, alkynes and dienes. And what we'll be studying in your second year is about alcohols, ethers, aldehydes, ketones, carboxylic acid, amines, nitriles. You come across all these terms like esters, amides, all this, okay? So here you can observe in the slides some more examples. You can take a screenshot of it. More example for alkanes, alkenes, alkynes, dienes. See, observe here whatever I discussed. How to write the structure of methanol. So butane 2-ol. Here you can observe 1, 2, 3. Count the number of carbon atoms. Here you have to count the number of carbon atoms from right to left because The OH functional group should get the first priority, correct? So that means I have to number from right to left. So it will be 1, 2, 3, 4. Now, 4 carbon atoms means butane. And OH functional group is attached to second carbon atom. So it will be butane 2 all. Is that clear? Now see how to name ethers. Observe here it is C2H5 OC2H5. So ethoxyethane CH3OCH3 methoxymethane. Now I told you when it is unsymmetrical, you have to name it with the you have to combine oxygen with the lesser number of carbon atoms. So this is methoxypropane, and since the methoxy group is attached to carbon number 1 of the propane, we call it as 1-methoxypropane. Same way aldehydes, you have to in the suffix you will be adding al. So the name goes on like this: methanal, ethanal, butanal, hexanal. And ketones, see the examples here for ketones: two alkyl groups bonded to the C double bond O carbonyl groups, and the both either side of the carbonyl groups you can see the alkyl groups. So the it gives the compounds like propanone, butanone, benzophenone. So these are the examples of ketones. See, so how do you write the structure of propanoic acid? This is for your practice. Okay, butanoic acid, benzoic acid to the benzene ring, C6H5 COOH, carboxylic group attached to bonded to benzene ring, we call it as benzoic acid. So just now I discussed some of the amines, how to name amines, nitriles, thiols, esters. Along with this functional group, students, also one more point I have to tell you along the functional groups, one more I have to include, that is haloalkanes. This knowledge also you should have. So what are halogens? Halogen means group 17 elements: chlorine, bromine, fluorine, chlorine, bromine, iodine. You know, right? Halogens, you are familiar with the halogens group 17 elements, right? Students, now for example, methane. How do you write the structure of methane? It is CH4. Now what I'll do, I'll remove one hydrogen. In the place of hydrogen, I will add any halogen. So now it gives you haloalkane. Now for example, what halogen I added here? Chlorine. So it is named as chloro. And one carbon atom to methane I substituted chlorine, right? Chloromethane. Okay, in the next class we will discuss in depth about this haloalkanes. In today's class I'm just giving you the introduction. Now for example, if it is C2H5Br, so what I did here, what is the general formula of ethane? It is C2H6. Now I removed one hydrogen and added bromine atom. It will give you the formula C2H5Br, which is nothing but bromo, halo, it go chloro, fluoro, bromo, iodo. It goes on like this. So the name of this compound will be bromoethane. Is that clear? So in the next class, just go through all the functional groups, how to name the functional groups, what is the suffix in the functional group, what you have to add, how to identify this functional groups. Students, this will definitely help for you to make the organic chemistry part will be easier. Okay, these are some of the basic knowledge that you have, that you should all have for the organic chemistry to be easy. So with this I conclude today's class. Revise well. In the next class, we will move on with the chapters. Thank you, my dear students. Thank you all.